Okay, hi everyone. I'm very happy to have a new chat today with Stephen Osserman. We are going to talk about a topic that I think is very special. I haven't heard many other people talking about it. That is simulation visualization. It's going to be clearer very soon what we mean by that, but maybe I'll let Stephen introduce himself for a moment so everyone knows who he is and what we're talking about. Hey, Stephen. Thanks for
Hi.
joining me.
Yes, thank you for having me. I'm Stephen. I have a background in data science and spatial analytics, and in the last 5 years or so, I've been transitioning more to data journalism and data visualization. And one of these topics that I've been interested in and kind of done in scattered different ways over time is visualizing simulations and simulated data. So excited to be talking about that with you.
Yes, so me and you have been in contact for now, a few months, I think, and talking about this idea of simulation visualization. And I now think that initially we got connected because I wrote something in the newsletter about simulation visualization, and you sent me a message saying, "Hey, that's what I do. We should talk." And you've done some really interesting work in that space. But why don't we define simulation visualization for a moment for the people who are watching? How would you define simulation visualization?
Yeah, so that's one of the research questions I'm interested in is how does it work to define? But I think of it as kind of a couple of different topics. One is the anytime that we're simulating data or that data is comes from models or simulations, and we as visualizers are working with that data, I think of that as kind of one wing of it. And the other is when we create simple simulations in order to communicate ideas or concepts. And in that case, we can be either using the simulation to not just generate data, but also explain processes or whatnot. And so I think there's a number of different buckets of work within that. And I think the best way to kind of understand is by sharing some examples. So I'd be happy to do that
Yeah, why
too.
don't we dive right in and you can share a few. I know you prepared a few.
Yep.
Yeah, let's go through a few examples and then we can elaborate on this topic.
Okay, sounds good. These are ones I've kind of collected from over the year and thinking about it. This first one is from The Guardian in 2014, and the first two I'll share are both kind of visual explainers of concepts in a data journalism context. And here it's kind of showing that how the measles vaccination rate among children offers protection not just to those who are vaccinated, but to populations as a whole. And it's kind of a very simple simulation that runs differently every time you run it. Again, kind of gives you this sense of this concept that might be hard to explain verbally, but pretty quickly can be communicated this way. A second data journalism example is from the New York Times in 2021, I believe. And here is a simulation that shows it simulates hypothetical workplace, and it has worked into the simulation kind of known forms of gender bias. And it's looking at this topic of how these kind of known, well-documented forms of gender bias can compound to lead to the kind of unequal society-wide results that we see. Um, so uh, a third example I'll share is a very different context. It is a company, AnyLogic, that has these different tools for building complex simulations of different kind of business and policy situations. And you build these agent-based simulations and can build dashboards along with them and get heat maps generated. This is from their pedestrian library, which can be used to simulate different environments and test changes to a shopping mall or an airport and or intersection and how people move through that. Next example is kind of a different category of simulation visualization, which is using simulation to quantify uncertainty. And this is from this, I think, 2014 or 2015 piece in the New York Times, How Not to Be Misled by the Jobs Report. And it takes this and says kind of based on what we know about noise, statistical uncertainty in the jobs report, in those numbers, we can say, like, let's imagine that the jobs just grew the same amount every single year. And then what would that actually look like? And it uses this technique of hypothetical outcome plots to show that. And this is, simulating from a statistical distribution to generate something. And I actually, before I got into data visualization specifically as a data scientist, I used techniques like these all the time to try to understand if patterns I was observing would likely be explained due to noise. Sometimes statistical tests are enough, but often this kind of simulation to show more complex systems and uncertainties are really useful. Another one that people will be very familiar with is the 538 simulation of election results. Their forecasts, their models through election systems come from them running. It's been a while since I've looked at the methodology, but I think thousands of times a simulation, and each one of these dots represents one simulation outcome. And they kind of visualize the outcomes of their fairly complex simulations in order to give a sense of like the distribution of what might be likely or possible, which is they've done work over many years on kind of honing this general approach. And then visualizing, moving on to kind of more complex and sophisticated scientific simulations that are often very hard to visualize well. One of my favorite examples of that is the Probable Futures project that I first learned about through their collaboration with Mapbox. And they were kind of taking this very, very complex climate model data, simulations of what the future might look like, and translating it into map tiles that could be then integrated for different visualization developers to use in their work. And there's kind of many steps of turning these scientific simulations into a product useful for visualizers to communicate with. And then the last one I'll share is kind of what I call simulation hiding in plain sight, which is the 10-day weather forecast. These are all based on weather simulations, and we don't think of it that way, but how they're choosing to visualize, what they're choosing to share and not share are choices that they're making. So that is a quick rundown of some very different contexts and examples of what I think of when I think of simulation visualization.
Yeah, thanks for showing so many examples. I think that there's another one from New York Times. I don't know if you would consider that a simulation as well. That I think it's extremely popular. That is the rent or buy. You know, the rent or buy.
Yeah.
That's. I think that's probably one of the most popular explainers, simulation visualizations created by the New York Times. I'm guessing. I don't know.
And I was actually looking for more examples like that. One of the things I love about the technique as a visualizer is having something that lets you kind of expose the knobs and let the viewer change different things and tweak different things and see how that impacts the outcome. And it's been a while since I've looked at the methodology of that. I don't know how they came to it, but yeah.
Yeah. So okay. So there are visualizations out there that visualize simulated data rather than data, right? So what is the difference? I'm guessing, right? So just how do we? What is the demarcation? I'm guessing, right? Normally, when we think about visualizing data, there's some sort of sampling process coming from some ways to sample reality, right? I don't know how else to say, right? That there's some sort of sensor or procedure out there in the world that takes a picture, right? Or sometimes longitudinal data over time, but it's sampling a reality, and that happened in the past, basically, right? But simulation is not like that. Simulation is data created by a computer program, right?
Yeah.
So that I'm guessing that's probably one of the major differences or useful ways to conceptualize the difference between the two. Would you agree with my characterization or not?
I think so. The snapshots that we take when we collect data, I kind of think about it as observed data versus simulated data as kind of one breakdown. And I feel like most of the data literacy out there that I was exposed to and that a lot of people I know kind of in visualization talks hear about is how to work with observed data and what to be aware of and what kinds of biases there are when we take that snapshot, what might be missing, or confounding variables that, correlation is not causation. All of these are things that are true about about observed data when we're looking for data points in the world. Obviously they're selective, but there's a whole different logic, I think, that is true about data that is generated from simulations. And there's different kinds of problems that I think we deal with. For example, I don't really think there's such a thing as confounding in simulated data. Somebody might argue with that, and this is just my instinct, but my sense is that instead what there are decisions built into the modeling process that account for certain variables and not others. And knowing what those decisions are and what kinds of questions it's fair to ask of simulated data is essential in order to kind of know what you're working with and what you're allowed to do with it. But it's a different set of problems. Another one that we don't deal with, I think, in observed data, but all the time in simulations is phase transitions, where an uncertainty thing might not just be you have slightly more or less of a number based on statistical noise, but it might be something all of a sudden qualitatively changes. And with the weather forecast example, that would be, you're forecasting rain, and then within your uncertainty window, the temperature is 3 degrees lower, and all of a sudden it's snow, and it needs to be dealt with very differently. That's something the city where I live, Portland, Oregon, does not always handle very well. But these are all kind of logic that's specific to simulated data.
Yeah, in a way, it's almost like, right, when you work with observed data, as I said, you're sampling a reality at that given moment, and that's it, right? But and also often you don't have a full picture of the data generating process, right? You actually try to reverse engineer that. But when you work with simulated data, you are engineering that whole process, and you know where it comes from, right? So that's a very interesting aspect. And I'm guessing the real challenge is the simulated data. How far is the simulated data from reality? And that's a whole different can of worms that maybe we don't want to discuss now, but I think it's a really important point. What I would like to discuss more is, okay, so we have simulated data. We kind of like agree that it's different in nature, fundamentally different than observed data. But from the point of view of data visualization, one may ask, okay, why study data visualization for simulated data? Isn't that just like, right? You're going to have some data types, some combinations, and you're going to, can you pretend that it's just like observed data, or there's something else, right? I think that's the $100 million question.
Yeah, I mean, my instinct again on this, and this is more an area of interest of mine. I have some experience in this a little bit, but I'm by no means have any qualifications that let me answer these questions. But my instinct in exploring them is
well, you do, because you've been. So I forgot to mention that you've been developing simulation visualization projects. So you do speak with authority.
Well, some, but not enough. I think what I'm excited about is that there are lots of different practitioners with expertise in kind of different areas of this who have taken it in different directions. And I'd love for there to be more of a conversation between them for all of us to kind of try to understand the answers to these questions. I think in terms of why to look at this and why to treat it as something distinct and different, is I do think there are distinct problems that we run into when we're trying to visualize simulated data. Some of these simulations that give a different result every time, like that Guardian piece of the measles vaccination. There's questions about how do you build a UX when you're not sure what the viewer is going to see. And one of the simulation-based visualizations I worked on was the People of the Pandemic game that Shirley Wu and I developed together, and I built the simulation for that. And that was something we spent a ton of time dealing with, is if every time someone runs this, they're going to get a different result. How are we kind of sure what the band of results are and whether an individual experience will be representative of the full picture? So that's a question unique to this kind of topic. And I also think it opens up possibilities that we don't have when we're dealing with observed data of, these issues of how you can quantify uncertainty and explore that through these techniques, and how you can let people turn their own knobs, like we were talking about, and explore how that changes the outcome of a simulation. Those are all all things that I see people doing, but I don't know how much it's been kind of formalized and how much we're learning from each other across fields, across disciplines, and developing a set of not only best practices, but inspiring examples that we can all draw from.
Yeah. And I think one reason why I am interested in this space and talking with you, you made me think a lot about what is special about simulation. And the first thing that comes to mind for me is this idea that when you work with observed data, it's basically, I keep coming back to this idea that is a static picture, right? But with simulation, now you have the knobs, as you just said, right? And turning these knobs create new results. And now you have a much more direct, you can do that with static data, except maybe just for filtering. You can change your level of aggregation, but it's very limited. You are not actually changing the nature of the process, right? And whereas with simulations, now it's almost like every time you turn the knob, you're creating a new data set with new settings, new parameters. It's almost like you are playing with that reality that we would like to simulate, right? That's what makes me really excited. And at the same time, the connection that I see with interesting problems in visualization research is mostly on this tight coupling between the interactive part and the visual part, because now you need to being able to interpret the effect of the things that you change, right, becomes really important, more important than usual. I mean, this is true in general for any interactive visualization, but I think here is crucial. Is like one of the main ingredients,
Yeah.
right? And even from a cognitive standpoint, the idea that you turn these knobs and you see something, and now you have to create in your mind a mental model of these relationships is something that you just can't do with static data, right? Does it make sense what I'm saying?
Yeah, definitely. And I think that's a lot of the most interesting questions are how to show that. And I've seen various examples that would let you kind of initially play with the simulation, and then as you continue, it says, okay, once we run this 10,000 times, here's what we see on average. So, and if you change this, here's what we would see on average as you go. And it's it is hard to figure out, and to I think it's specifically true for the kind of small scale demo simulations that we control ourselves. This is where I might slightly disagree with what you were saying about like we control the process of the data. Is in many of these examples, they were actually based on kind of complicated scientific simulations, and we're dumped a bunch of data as a result of that. And whether that should be part of the same conversation or a different conversation, I'm open either way. But I do think that even in those, there's similar questions that we need to ask, and in some ways, it can be useful to like unmask some of that process, even if we can't recreate, on somebody's web browser this incredibly complex everything that went into the simulation. We can show some of the factors that went in and some of the outputs, and maybe there are enough different runs that we can, show under 3 different sets of assumptions how the outcome looked different. Even if we're not letting people kind of control and fine tune everything. So it feels like a broad spectrum, and how much control we have over the data, how much we know about the process that generated it, and how much control we give a viewer of a project to be able to explore those questions themselves.
Yeah, and you just made me think about this aspect that is definitely not a minor aspect, that simulations can be really complicated and you might not be able to interact with them. And that's a huge problem, right? And it's a problem that has value across data visualization and other areas of computer science, right? I imagine things like databases and algorithms and data visualization coupled together, because if you now want to make something that normally is not interactive, you want to make it interactive, you have to find ways to reduce the computation time and data size somehow, right? And I now remember we had this conversation about projects where there's this trade-off between the accuracy or precision of the simulation, sorry, and interactivity, right? Where do you draw the line? Is it better for, say, a scientist to have a coarse simulation of something, but being able to change parameters quickly, or wait and see, right? Or maybe there are even other procedures where you can run many things in parallel and compare. I'm sure there's a whole design space of solutions out there, but this seems like a non-trivial aspect of the problem, and it does seem like eventually it is a visualization problem. It's not just an algorithmic problem.
Yeah, that's one of the areas of this that I really do not have expertise in, and I'm very curious about is how within different domains, people who are working on those technical aspects are thinking about visualization. So people who need in either complex business settings, who are modeling different kinds of simulating different ways that a decision might have, you know, different downstream effects, how they're thinking about communicating and visualizing that, or scientists who are working with these highly technical simulations, how they're communicating what their findings are and where visualization fits into that. So that's definitely an area that I'm also interested in, this kind of before we get to the step of communicating to a general public about findings of a simulation.
Yeah, and I'm now thinking that maybe the closest thing we are normally used to is visualizing forecasts. That tends to be a little bit more common in let's say, quote unquote, standard visualization, right? The idea that there's a future predicting procedure, and now you have possible futures, right? For sure, one of the most common ones is definitely in climate change, right? These popular visualizations of possible futures, but in general, I can imagine many other areas where forecasting is one of the main points. Would you consider forecasting a form of simulation?
To me, definitely. I think most forecasts are kind of built on that. I think to answer about what is not simulation is a lot of people would say a purely mathematical model that takes inputs and uses some mathematical formula to generate the outputs. Some people would say that's a pure form, but anything that is kind of sampling from different possibilities or in order to generate things is a simulation. And I think most forecasts lean in that direction.
Yes, and I think some of the conversations that we had, I've been observing this fact that it looks like there's not a lot of, I mean, for a person like me who spends a lot of time in research and academic settings, I don't think that's a problem that has been somehow identified very well as an interesting area of research. Even though I would say that there's a long tradition of visualizing scientific simulations, so that for sure in scientific visualization there's a lot of that, but it tends to be closer to problems of computer graphics problem and problems of how to be as let's say as precise or less accurate as possible with the fewest resources, right? I hope I'm not mischaracterizing our whole area of research. I'm definitely not the best person to talk about that, but I haven't seen much about this idea of more abstract simulations, right? Simulations that produce data about phenomena that are more abstract, they're less tied to physical phenomena, right? Scientific visualizations tend to be a lot about physical phenomena, whereas here we tend to talk more about abstract data, right? And things that don't have a natural physical representation or natural metaphor, which I think is an interesting aspect. And the other one is what I mentioned earlier, this idea of understanding the cognitive aspects of it, right? What works in terms of figuring out things, right? Because in a way, I'm now thinking that when you visualize observed data, it's almost like implicitly you're trying to understand the reality that is described by that data. But in simulations, you don't know how close to reality that simulation is. So it seems to me it's more like a thinking tool, right? It helps you think about the problem in a way that you understand the problem better rather than what happened in the world. Does it make sense to you?
Yeah, I mean, there's always,
I'm
this is
trying
the
to find the right words for a
big
concept that I have in mind.
yeah, I mean, I think it speaks to what I've heard as a big critique of simulation in policy and in social sciences, is that it's easy to tweak the parameters in order to get whatever result you want, is kind of the critique. And I think that's overstating it. I think there are ways that you use careful, legitimate methodology to address some of those issues. That field of simulation within social sciences, I think, has come some distance from just anybody plugging in the numbers they want to get the outcome they want. But there is still
Yeah.
something true that if you're expecting certain behaviors, it is easy to kind of set up a program that will either generate those behaviors or not. And in some cases, I think that it is more useful for helping people understand how, like, what might be true, what might be a plausible path that you go from, in the case of the New York Times opinion piece we shared, from these kind of known, well-documented areas of gender discrimination, like the kinds of things that women are more likely to have reported on in evaluations than men, how you go from that kind of thing to broad discrepancies in how many executive officers of Fortune 500 companies are male versus female. And it's not that it's saying this is the mechanism, it's saying that this is a plausible path from one to the other that can be explained very well through the simulation. So I think it's kind of halfway between trying to use simulation to explain what is and to give people a sense of how we might go from point A to point B in what we're observing in the world.
Yeah, this is super exciting. I hope that people watching and listening get as much excited as we are. I think a final question is, what can we do? Or maybe if somebody's listening, well, let's start from a different thing. If somebody listening and is excited about this idea, what should they do? Where do they start?
Yeah, I mean, for me, I'm at a stage of loving to talk about this, occasionally getting to incorporate it more into my work, other times doing more, visualization of observed data. So if you're someone who's interested in this topic or have expertise in it and want to be in dialogue, like I know two of us are definitely planning on continuing to talk and inviting other people into that conversation. So please feel free to reach out and let us know what your thoughts are on it.
Yeah, and when I'm publishing this, I'll put some of the links that you shared with me and the ones that you showed at the beginning. And me and you have been talking about ideas to make this more popular and maybe trying to gather people around this idea to see maybe some of the people who have already worked in this space and maybe organize an event around it. Let's see. But I do think it's a really interesting niche and there's way more to do. And I hope that people listening to this will get excited about it. And other than that, thanks so much for agreeing to talk with me and get this recorded and share it with the world. And me and you, we will keep talking, and we'll keep talking about it in the newsletter. And let's see what happens next.
Great. Thanks so much for having me. It was a pleasure to chat about it.
Thanks so much. See you soon. Bye.
Bye.